In AI engineering, when you store notes in a vector database for retrieval, you first turn text into an embedding vector. Today we'll build a PII safe note store and find a subtle bug where sensitive data slips into the embedding itself. By the end, you'll know exactly which text must be sanitized and when. We start with a fake embedding function so this whole file can run on its own without a real model. We create a 3-slot vector, all zeros to begin with. Then we loop over every character in the input text. For each character, we grab its numeric character code. We add that code into one of the 3 slots, chosen by the code modulo 3. Finally, we return the finished vector for that text. Next, we set up a simple array to act as our stored rows. We wrap it in a fake vectordatabase object. Its upsert method just pushes each row into the store array. Now the important piece, a redactor that strips personal information from text. The first replacement swaps anything that looks like an email address for an email placeholder. The second replacement masks 9-digit social security numbers in the classic dashed format. The store note function ties everything together, starting by redacting the incoming note. We embed the safe, sanitized text rather than the raw note. Then we upsert a row holding an ID, the embedding, and the redacted text. A main function feeds in a raw note with an email and a social security number, then reports what was actually stored. Let's follow a real note through the pipeline, starting with the raw string in main. When we call storeNote with that raw string, the very first thing it does is run the redactor. The redactor scans for an email pattern and swaps john@acme.com for the placeholder email. It then matches the 9-digit social security shape and replaces 10023456789 with the SSN placeholder. So by the time we reach line 23, Safe holds the note with both secrets stripped out. Crucially, we hand that sanitized Safe string to embed, not the original note. Inside embed, each character's code is bucketed into one of 3 slots to build a tiny vector. That vector, along with the Safe text and a generated ID, gets written into the store. Back in main, we pull the first row out of the store to inspect what actually landed. The result shows the redacted text and a vector built entirely from that clean version. The whole point of this flow is that the embedding must never see the original text. It's tempting to redact the text you store but still embed the raw note, because that feels more accurate. The reason this leaks is that an embedding is not a one-way summary. It's derived directly from the characters you feed in. Look at how our fake embed function works. Every character's code is folded straight into the vector. Real embedding models are far more sophisticated, but they share this property. Sensitive tokens leave a measurable fingerprint in the output. That fingerprint matters because vectors get stored, indexed, and searched, often in a system with looser access controls than your main database. So even if the stored text field is perfectly scrubbed, an embedding of the raw note quietly smuggles the email and SSN into your index. The fix is simply the order of operations. Redact once, then feed that single safe string to both the embedder and the stored record. Because embedding and storage both draw from the same sanitized value, there's no path left for personal data to escape into the vector. Redaction only protects data you actually redact. Embeddings encode their input, so embed the safe text, not the raw note. One wrong variable, note versus safe, can leak an email and SSN forever. If that helped, subscribe for more.